Hey you guys, so I forgot to hit the record button during class, so I'm going to just do a short video here and run through the major points. I'm not going to do every single question that we did in class, and it's really not important for you guys to do every question either. It's just more the whole point of it. So I'm going to zoom in to this number one right here. So what we're doing is we're trying to figure out the area of these boxes, and if you notice, each of the boxes is attached to the parabola on the left side of the box. Okay, hopefully you can see all those lines and dots that I'm making. It's attached in those places. So obviously you can count on this one how high it is. This first box, we'll just call them 1, 2, and 3. The first box is 12 units tall. And it's 1 unit wide. So 12 times 1, obviously, is 12. You can see that the next box is 7 units high and 1 unit wide, so 7. And again, you can see the third box is 4 units high and 1 unit wide, so 4. If you wanted the area, you would add them up. 12 plus 7 plus 4 is 23. However, I'm asking you to do this because it will help you with Chapter 7, help get your brain kind of wrapped around what we're doing. If you were on a problem that didn't have a scale or it didn't end up perfectly on 12, like maybe it was 11.5, the way that you can know is you can tell that this is going to hit at 12 because if you were to plug in -2 to the equation, you would get 12. Okay? So I format it like this. F of -2 is 12. I'm hitting that point at 12. Well, where would this point come from? Well, let's use this color. This point would come from -1. And this last point would come from 0. Okay? So what I want to do is show you on a calculator how you would get those numbers if you didn't know, if you couldn't quite see them. So I'm going to go to this graphing calculator. And I am going to hit this y equals button. Maybe I should get the marker so you guys can tell what I'm hitting. Okay, so just now I hit this y equals button. I'm going to type in the equation x squared minus 2x plus 4. I was looking at a different question. X squared minus 2x plus 4, that's the question that we're on. Okay, so this is the equation we're on. Now I'm going to hit table to do it. Since it's that other color, we're going to hit second first, second table. Okay, mine is counting by 0.5s because it comes in handy later. Sometimes they're a half a unit apart. That's okay, we can just scroll through here. And we had said that we wanted to know what happens when it hits -2. Well, that's where the 12 came from. And -1 is where the 7 came from. And 0 is where the 4 came from. Okay? Okay, so on this one, your rectangle is 7 units high, 2 units wide. This one is 5 and 2, and you can figure out your area that way. You can also add up the little boxes if it's a perfect one, if it's really nice. Okay, but I'm going to try and do one that's not perfect. So let's look at question 3 here. Do you see how this first box does not hit perfectly at a number? We have to figure out how tall that box is. So it touches the x-axis at -3, so we're going to plug in -3. The second box starts at -2. Well, we're going to figure out what we get at -2. The next box is at -1. And the last box is at 0. Now notice we are going all the way to 1, but we're not going to use 1 because that doesn't make another box. Okay, that's not how tall a box is. Okay, so let's go back to the calculator. Do this one more time, and then I'll just pretend like you know how to do it in the calculator. So negative 0.5 x squared minus x plus 5 table. Okay, there you can see when you plug in negative 3, you get 3.5. When you plug in negative 2, you get 5, etc., etc. So 3. Oops, I'm still erasing. 3.5, 5, 5.5, and 5 again. So that's how tall the boxes are. In this instance, all the boxes are 1 unit wide. So remember, area is length times width. 3.5 times 1, 5 times 1, 5.5 times 1, and 5 times 1. Now obviously, since they're all times 1, you don't need to count them, but it won't always be that way. The next one we'll do is one that'll be a half. So that will change the problem, but in this instance it doesn't because they're all 1 unit wide. You should get 19. Okay, let's do question 7. Oh, I can't do question 7 because it's, if you see, it's like hiding behind this page, and I'm not going to grab my computer to fix it. Let's do question 14. Okay, so this is what I mean here on question 14, how they're not always a unit wide. I'm not going to worry about the tops of it right now. I'm just going to draw on the bottom here. So if you can tell, all of these boxes are a half a unit wide. Okay, we have to figure out how tall they are. Well, I did skip the directions that changed. So on the first set of directions, it said that they were left endpoint rectangles. These are right endpoint rectangles. If you can see, the top of this rectangle is connected to the parabola on the right. Maybe I should use a different color. Can you see that red better? The top of that rectangle is connected on the right. The top of this rectangle is on the right. On the right, on the right. So we need the right for x values. So this x value is at 1, 0.5, 0, and negative 0.5. We don't need to use negative 1 because that height is not the height of a rectangle. So these are the values that we're going to plug into our calculator. Go ahead and zoom out now. So when I plug in negative 0.5 and 0 and 0.5 and 1, I get 9.75, 11, 11.75, and 12. Now, I am not just adding those together because we're counting area. We're not counting how high is everything. These are the heights of the rectangles, but every rectangle is a half a unit wide. So what you could do is you could just multiply these all by a half separately and then add them all up. I'm going to write this out a different way so that you could see something that's going to be important for Unit 7. So I'm going to write all my 1/2s first instead. And then what we're actually going to do, since they each have a 1/2, we can factor the 1/2 out. And we're left with 9.75 plus 11 plus 11.75 plus 12. So what you can do is if you have a half, or in calculus and all, it's going to be nice numbers. It could be 3/4 or 1/4. You can take that number and factor it out. Now, they do all have to be the same size. I could give you some rectangles where some of them are 2 units wide, some are 1, some are a half, and some are like 4, okay? But as long as they're all the same, you can use this method, and that's what a lot of the next unit's going to be about. And then if you add all this up, you get 22.25. Now, last one I want to talk about real quick is 18. Because it's trapezoids, so when you're drawing it, it's connected right here and right here and right here. You see your trapezoid? On all of these, your trapezoids are sideways. Maybe I should draw this picture. This one looks like one big trapezoid, but it's actually 3 trapezoids. And your area of a trapezoid is 1/2 base 1 plus base 2 times your height. Well, on that first, trapezoid, what's your bases? Well, your bases are the ones that are parallel to each other. So it's actually these two, and this is your height. Okay? So when you do this one, we've got 3 trapezoids. I know that the middle trapezoid looks like a rectangle, but we're going to use a trapezoid anyways. Because technically it is a trapezoid. They're telling you in the directions you're using trapezoids. And a rectangle is a trapezoid. But it gives you the same answer anyways. So we have 3 trapezoids. 1/2 base 1 plus base 2 times height plus 1/2 base 1 plus base 2 times height plus 1/2 base 1 plus base 2 times height. So this first trapezoid, base 1 is 2, base 2 is 10. The height, this direction, is 2. In fact, all of their heights are 2. This middle trapezoid, base 1 and base 2, are both 10. And the last trapezoid, base 1 is 10, and base 2 is 2. Now there is a reason that these 10s are the same and these 10s are the same. Not that they're the same as each other, but these 2 10s are the same because they're both this side. It connects both trapezoids, and the second 2 is this side. It's just a coincidence because it's a nice parabola that they're the same number. They wouldn't necessarily need to be the same number. So now what I'm going to say is, well, everything that has a 1/2 in it, everything has a 2 multiplied to it. So let's go ahead and factor those out. I'm going to factor out a 1/2, and I'm going to factor out a 2. And I know this is a really weird way. Like, you could be like, oh, I'm just going to type it in my calculator. But I'm trying to show you this way because it's going to really help you with the calculus part of it when you get there. So what's left? Well, everything that I didn't highlight is left. 2 plus 10 plus 10 plus 10 plus 10 plus 2. And like we said, these 10s match. That's these ones. And these 10s match. You could pretend they're a different number too. Pretend the first 2 10s are 10s and the second 2 10s are 20s. But so this makes 1. There's 2 10s. There's 2 10s and 2. This part right here is going to become really important because pretend we couldn't see the graph. You didn't know it was 10. Well, you have to plug in a number. You know, we said f of 3.5. Well, I'm going to find f of 0 and f of -2. They might not be the same number. They're not going to both be 10. But so here's f of 0. Here's f of -2. Well, just trust me, that's really going to help you. So if you can figure out where the numbers went, not necessarily why I put the numbers where I did, but if it logically makes sense to you why the 1/2 can go here, why I can do this, then you're going to be on track. Set to go.